Assalamualaikum and hello. In this video, we are going to learn about sound behavior. We have learned about the definition and properties of sound. Now we are going to understand what happens when sound wave propagate from its source and when it hits a solid or other material. Propagation of sound. So propagation of sound is transmission of sound in a particular direction or through a medium. So this image shows that sound propagate in a sphere shape. And when sound propagate, attenuation will happen, which means when sound propagate away from its source, it will become weaker. So let's say at R radius, the sound intensity is I. When the distance doubled, the intensity become 1/4. Okay? And then when the distance tripled, it become 1/9 the intensity. When a sound becomes further, or when there's a lot of sound source in one line, we will consider that sound propagates in a cylinder form or from one line source. For example, imagine that there is a sound source in the middle of the sea. When the sound reaches the top and the bottom area, sound will propagate differently. The same thing happens at a highway. When there's a lot of car, there's a lot of sound source. So instead of calculating each point source, it is considered as line source of sound. So sound behavior. Okay, when sound hits a surface or when it's propagate in different medium, okay, propagate means like move, okay, so when sound move away from its source in different medium, a few reaction happens. So I'm listing 6 of it here, but if you do a further study on this, you may find a few other terms. Now the first one is reflection. When a sound wave encounters a sharp discontinuity in the density of a medium, or in easier way, if sound hits something, some of its energy will get reflected. So almost perfect reflection of sound happens on smooth and hard surface. An example of event caused by reflection is echo. The next is reflection. So if the surface is concave, the reflection sound will be focused at one point. That is why when you are in a mosque, you can hear the lecture even though the speaker didn't use a microphone. While this design is common in mosques, it may not be suitable in spaces of different function like auditorium and areas where high level of privacy is needed. Next is diffusion. When a sound reflects off a convex or uneven surface, its energy spread evenly rather than being limited to a discrete reflection. So this is the opposite of concave surface just now. Okay, this is concave. It focuses to one point. This is convex. The sound spreads away from here. So ceiling sound diffuser usually use convex surface to distribute sound throughout an area like auditorium and open office. Okay, next one is transmission. When sound vibration hits a solid surface, it continues to vibrate through the material and makes the air on the other side vibrate too. To reduce sound transmission, we need sound absorption. Sound absorption is the loss of sound energy when sound waves comes into contact with an absorbent material. So just now the incident sound is here and most of the sound is transmitted to the other side. But if this material is absorption material, it will get absorbed here and only some of the sound transmitted into the other side. Sound refraction. How does refraction happen? The direction of sound is altered when sound waves encounter changes in the medium condition that are not strong enough to cause reflection, but enough to change the speed of sound. Now, if you remember in our previous lecture, we already learned that sound travels in different speed through air with different temperatures. So in lower temperatures, it's slower and it's faster at higher temperature. Now during daytime, sun heats up the Earth's surface and warming the air close to the ground. But during nighttime, when there's no sun, the ground cools quickly, which results in the air near to the ground to be cooler than air that is away from the ground. So what happens when there's sound wave? Now refraction happens because there are changes in temperature and air density. So during nighttime, sound wave will bend towards the ground because the temperature is lower here. But during daytime, sound will bend away from the ground towards the cooler air. Another factor that causes sound refraction is wind. To help you understand better, let's have a look at this image. You might still remember refraction of light that you learned in school. So water is much denser than air. So when light goes through, from air to the water, it will be refracted. The last reaction is sound diffraction. So sound diffraction happens when the direction of sound changes as it passes through an opening or around a barrier in their path. And then this one shows how diffraction happens at a solid wall. It roughly shows how we hear sound at this area. So sound will become slower and slower when it becomes nearer to this acoustic shadow zone. The previous explanations are all theoretically. In real life, when the sound propagates, a few reactions happen. For example, let's see the first one here. Reaction of sound in a room. So when the radio is switched on, sound will propagate and reflect at walls, floor, and then reach the listener. Other than that, sound will also propagate directly to the listener. It will also propagate to the ceiling and diffuse throughout the room, and then again reach the listener. For the second example, when a sound hits a wall, it will transmit, absorb, reflect, and diffract. Okay, just now I mentioned here diffusion. So diffusion at ceiling will happen if there are diffusers. For flat ceilings like this, of course, reflection will happen. Sound will propagate to the ceiling and then it will be reflected to the wall or directly to the listener. Now imagine that you are in Dewan Budaya. When there's a performance, the sound will propagate from the source, which in this case is the stage. If there is a big column inside the hall, diffraction will happen around it. Okay, so if you're sitting behind the column, you won't be able to hear the sound well. But if you are sitting or standing far away from the column, but still the column is between you and the stage, you won't be able to detect the presence of the column from the nature of the sound. Then if there's a small opening, if there's a small opening at the main door, sound diffraction will occur. If you're standing outside the hall, you will hear the sound as if it's a localized source of sound. If you're standing here, you will hear as if this is the source of the sound. Now, the following lecture on sound control are based on what we have learned about sound behavior. So make sure you understand about sound properties and sound behavior because it will help you to understand more on noise reduction and acoustic design.